All right, so in doing this problem, this is using what we did yesterday, of course, where we have to see, is there a single number where if I multiply it by 2, I get the 12? And the same number where if I end up squaring it, I get the 36. And so let's check that. So 2 times what's going to give us the 12? 6, okay. What squared equals 36? 6. It's the same number. That tells me that I can go ahead and factor this. And so it becomes x plus 6 squared. Now make sure you have that correct on your paper because we're about to use that in a different way. We're about to use this to do something that we couldn't have done before. We're going to be solving this equation. Notice it's very similar to what you just had. Please write the whole equation down, and we're going to walk through the process about how do we solve something like this. And as you're writing it out, I want to point something out. We could not solve this equation without what we learned yesterday. We cannot solve this without solving it first, at least not without some very advanced, messed up, tricky stuff that we aren't getting into right now. Because, like, if I tried to take the square root right now, I'd be trying to take the square root of 12x. That is not going to work out nicely for us. And so we need some way that we can get rid of the squared without ending up with some really messy square roots. And so that's where we go into the factoring that we were just talking about. So first thing I want to do, I want to factor the left side of this. Now we already talked about what that gives us. That's going to give me x plus 6 squared. Now in this case it equals 16 because that's what was on the right side of the equal sign, and so it's still what is on the right side of the equal sign. We didn't change any of that kind of stuff. All right, now that we've got it set up like this, I now can get rid of the squared. Because notice now if I take the square root of the left side, and yes, I want to show it that way. I want to show where I take the square root of the x plus 6 squared. Notice if I do that, I'm going to end up getting rid of that squared on the left side. I'm just going to have that x plus 6 over there. That's the advantage of doing this. Now on the right side, since I took the square root on the left, I also have to take the square root on the right. So I take the square root on the right side, so square root of 16, and when I take the square root of both sides, what do I need to include?
Plus and the minus.
Yep, the plus and minus. So we got plus or minus 16, so this x plus 6 actually equals plus or minus 4. And so we're actually able to start solving this where we couldn't before. Now, at this point, we're going to have to get the x by itself, which means moving that 6 out of there. But I don't really like this plus or minus 4 sitting there as it is, sitting there as a plus or minus 4, so I'm actually going to rewrite this line. I'm going to rewrite it as x plus 6 equals 4, and x plus 6 equals negative 4. Because that way, I'm actually going to be doing it to 4 and negative 4 separately, not like trying to do it to this plus or minus 6, which is like two numbers in one, kind of a weird thing. All right, so now, x plus 6 equals 4. I want to subtract 6 from both sides to get the x by itself. So we go x equals, and the 4 minus 6 is negative 2. And then on the right one, I have x plus 6 equals negative 4, so again I'm going to end up subtracting 6. And so we end up with x equals negative 4 minus 6 is negative 10. And so those are our two answers. We got x equals a negative 2 and a negative 10. All right, so for doing this one again, we still are going to start with the same basic idea of looking to see, can I go ahead and factor that left-hand side? So is there a number where 2 times that number gives me 18, and that same number squared gives me 81? So 2 times what is 18? 9. What's 9 squared?
3.
9 squared is
3.
81.
What the heck?
All right, so since 9 will double to give us 18 and square to give us 81, that does tell me my factor form. It tells me I can write this as x plus 9 squared equals 100. And once I've done that, I am now going to be able to solve this equation, because solving it from here is actually now going back to old techniques. So I'm now going to square root both sides in order to get rid of the squared. So we're going to go square root of x plus 9 squared equals square root of 100. And remember, when you include that square root, that's where I want to see that plus or minus included. If you do not include it there, and decide to just put it in at some step later, you're actually just putting it in where it didn't necessarily come from anything. It's just like, oh, well, I know I'm supposed to throw it in somewhere, so I'm just going to toss it in here. This is specifically where it's supposed to go. Is it's introduced when we take the square root of both sides. All right, left side of our equation now. The x plus 9 squared, when we take the square root of it, it goes away. We've got just x plus 9. And then that equals plus or minus the square root of 100. And the square root of 100 is 10. All right, and then, like before, yes, I'm going to have to subtract the 9 to get the x by itself, but I don't want to do plus or minus 10 minus 9. That's weird. I'm like trying to do two numbers minus one number. It's not quite right. So let's break it up into two separate pieces here. We're going to go x plus 9 equals 10. And we're going to do x plus 9 equals negative 10. And then we go ahead and subtract 9 from both sides. So for one of them, we get x equals 1. And then for the other one, we subtract the 9 from both sides. And there we have x equals, we start at negative 10, and then we go down 9 more. That means we're even more negative. And so that's going to be a negative 19. So those are our two answers.